Hey everyone, welcome back to our Python series. My name is Ansh Patania, and in previous video we learned some core concepts of Python, which is strings and conditional statements. In today's video we are going to talk about list and tuples. So without wasting any time, let's get started. Before we type our first line of code, why are lists and tuples so foundational in production software engineering? Whether you are pulling records from SQL database, receiving a payload from a REST API in JSON format, or managing state in web frameworks like Django or fast API data almost always arrives as a collection of items. Knowing how to manipulate, filter, and extract data from these collections efficiently is what separates someone who just knows syntax from a developer ready for production code. Our first topic will be indexing. So, first, think of a list as a train made up of separate storage cars. Every car holds an item, and each car has a numbered seat position called an index. Just like with strings, Python starts counting list positions at 0. If I want to access the very first item, I use square brackets right next to our variable name. Let me explain you this in example. You can copy these lines just by pressing Alt Shift and down arrow key. Now here is a major trap that catches beginners constantly. What happens if you try to pull an index position that doesn't exist? Now if I print shopping cart 10, let me print shopping cart 10. First, let me run this code. As you can see, at the very first index 0, there is apple, and at the second index 0, 1, 2, milk. At the second index there is milk, and at -1, negative index, there is bread. Now let me show you. If I print an index which does not exist, here as you can see, Python throws an index error, list index out of range. Why does this happen? Because Python allocates specific memory positions for the list length. It stops counting where the list ends. If you aren't sure how many items are in list, always verify using them with len function first. Let me show you the example of len function. Print the len of shopping cart. Oh, let me wait. Comment. Here, the length of the shopping cart variable, the length of the list, this one, is 4. Also, unlike languages like C++ or Java, Python lists can hold mixed data types in a single list. Now watch this. Let me make another variable, user data equals to Rahul, comma 28, comma 99.5, comma true. Let's take a boolean value. Okay. Now you can mix strings, integers, floats and boolean because Python lists stores memory reference. Also called, these are called pointers. Memory reference is called pointers to objects rather than contiguous raw value. Now as you can see here, let me uncomment this. Here I have used negative index. Negative index works backward from the right hand side. It will work backwards from the right hand side. -1 gets the last item, -2 gets the second last item. If I write here -2, this will give me the second last item. Let me comment this and let's run the code. Milk. Look at this. It has given me the second last item. Now, what if we want to extract a subsection of our list? This is called slicing. Subsectioning is called slicing. Slicing follows the exact same formula as strings. Let me show you the PPT. Yeah, here you can see I've added the slide of slicing, range and sub-ranges. Now slicing follows the exact same formula as strings. You have to make square brackets and the start, colon, stop. Python includes the starting index but excludes the stopping index. As I told you earlier in the last video in strings. Let me explain you with this an example. Oh wait. Let's take an example. Print shopping cart 1 to 4. It will extract. Let me comment this. Wait. We don't need this anymore. Yeah. It will this slicing 1 to 4. It will extract banana, milk and eggs. Let me show you. Yeah, you can see the output here. It has extracted the banana, milk and bread. As I've told you earlier, it will include the first index, the starting index, where we are starting from. This is 0. We are not starting from 0. We are starting from 1. We are starting from banana. It will include banana 1, 2 and 3. We don't have the fourth value, so here it will not include that, and it will print banana, milk and bread. Now let me show you another example. Shopping cart. Now look at this. It will start the default value will be 0. If you will not enter anything, if you will not give any value to the starting index, it will automatically sets to default 0, and it will start from apple, banana, milk. It will not include bread because it will not include the stopping index. Now let me give you another example. Let's run this. Look at this. It will extend all the way to the end from second index 0, 1 and 2. It will start from milk and extend towards the end to the up to bread. Now let me give you another example of. Let's first uncomment this. This will reverse the list. First let me comment this out. Yeah, here it will reverse the string, reverse the list. Basically it will reverse the sequence. It will start from banana, milk, bread, milk, banana, apple. Now if you want to prove the mutability, basically lists are mutable. Overwriting an element directly in memory, it is possible in lists, but it is not possible in tuples. Let me show you how. Shopping cart is equals to, let me here give an index 1. I have to change the value of index 1. Mango. Let's print the whole list. As you can see, it has replaced, the first index is replaced with mango, as you can see here in the output. Apple, mango, milk, bread. It has replaced banana. Now I want you to pause the video right now for 10 seconds and test yourself. Look at our modified shopping cart in your terminal. Write a slice that extracts just milk and egg. Here I have not written egg, but let me check. Basically I'm teaching you from my PPT. I've made notes. Yeah. Now you can see that mango, milk, eggs, bread. Yeah. So wait a minute. Yeah. Now in a terminal write a slice that extracts just milk and eggs. Did you figure it out? The slice is shopping cart. If you include, let me comment this out first. Yeah. Now let me do it for you guys. Shopping cart will be 2 to 4. Oh. Here it will print milk and eggs. It will include the starting index 0, 1, 2. Here it is included the second index and it will go till the third index because it will not include fourth. Now if you got that right, which is a good thing. Now our topic second is essential lists method. Now I want to show you some methods of lists. Built-in method lists: append, insert, remove, pop, sort. There are so many methods. You can search them online, or you can also use ChatGPT. Now Python lists come equipped with built-in action called methods. These let us add items, remove items, or reorder our data dynamically. Now let's write our code. Apple and the append function is used to push the new item to the very end of the list. If I write something in these bracket, it will push the new item to the very end of this list that I've made at the top. Now if I add anything, suppose I'll add cherry. Let's run the code. Oh, I have to print it also. My bad, guys. Yep. Now as you can see, the append function pushes the new thing to the very end of the list. Now let's move to our another method called insert. Fruits dot insert. Now as you can see, the insert orange into index 1, shifting everything else one spot to the right. If we write here index 2, let me show you guys. As you can see, if we write here any index, it will insert the orange there and push everything to the right. Now let's move to our next method called remove. Now as you can see, remove is a very basic function. It will remove any item from the list. Bananas. Suppose we have to remove banana from our list. As you can see, it has removed banana from our list. Now let's move to our next method called pop method. Let's make a variable that popped item. I'll explain you later. First let me write the code. Fruits.pop. Print popped item. Print fruits. Let's do this. Now, oh wait, yeah. As you can see, dot pop removes and returns the last element. Notice how we captured that removed the pop item inside. You can see this. It has removed the last element from the list and popped it out and give us the remaining string. Now our next method will be sort. Let's make another variable. Numbers is equals to what we select. We have to make a list here. 11, 90 and 3 and 25. Let's take these numbers. Numbers dot what we have to do, sort. Yeah. Let me write another variable. Print numbers. Yeah, let's run this. As you can see, the sort arranges number from the smallest to the largest and reverse flips the entire list direction. As you can see here, I have written a random sequence here: 42, 11, 90, 3 and 80. It has arranged it. It has basically sorted it into an ascending order from the very lowest number to the highest number. And as you can see, reverse has just reversed the list here. 90, 42. It has just reversed this list. 90, 42, 25, 11, 3. Now here's a critical point that interviewers love to test and that trips us beginners every single day. What happens if you try to print dot sort directly? Watch this. Let me delete this. Yeah. Let's make a list, some numbers, print sort, print is score dot sort. Let's run this. The output will be none. Why did it print none? Because list methods like dot sort, dot append and reverse modifies the list in place and returns none. If you want a brand new sorted copy of a list without altering the original data structure, use Python's built-in sorted function. Instead, clean copy is equals to sorted in bracket scores. I hope you understood that. Now, oh wait. Now our next topic will be advanced list operations. We can also combine lists together using operations like operations or make independent duplicates of lists. Let's see how list concatenation and list copying works. Let me give you an example. List A is equals to, let's take numbers. List B is equals to 4, 5, 6. Now concatenations means using plus symbol, plus sign. Combined list is equals to list A plus list B print combined list. Now the output will be, it will combine these two lists 1 2 3 4 5 6. Let's run the code. Oh, I've done a mistake. There is a spelling error. Now it will run. Yeah, as you can see, it has combined it has concatenated the two lists which I've made, list A and list B, 1 2 3 4 5 6. Now our next method will be repetition. We do repetition by using multiply sign into. Repeated list is equals to list underscore A into 2. Let's print our result. As you can see, it has repeated list A 1 2 3 and 1 2 3 two times. If we do it there 3, it will repeat 3 times. 1 2 3 1 2 3 1 2 3. If we write here 4, it will repeat 4 times. 1 2 3 1 2 3 1 2 3 1 2 3. Now let's move to our another example, reference trap versus real copy. Let me explain you with an example. Original is equals to 10 20 30. Analyze list is equals to original actual copy is equals to original copy. Let's run our code. Oh. There is a spelling error again. Again? Oh. My bad, guys. Wait. Yeah. It will copies the memory reference, not the data. It will not copy the data here. This will create the memory reference, and this will create a distinct copy in the memory. It will make changes in the memory, not here, not in the output. Okay. Now, original is 0 is equals to 99. Print list. Let's print copy. Let's run this. Yeah, as you can see, the output, it has changed to 99 20 30 and 10 20 30. The alias list is 99 20 30, and the output and the actual copy is 10 20 30. Now look closely at 11th line. 11th to 16th. Okay, when you write alias list is equals to original, you're not creating a new list, you're simply giving the exact same memory location a second nickname. Changing original automatically alters alias list. Always use dot copy or slice copy, copying original, if you want to modify a list safely without corrupting your original data sources. Okay, now let's move to our third part, tuples. Tuples are basically immutable, as I told you earlier. Lists are mutable, tuples are not mutable, tuples are immutable. Now, what if you have data that never want your program to accidentally modify or delete? Things like database configuration settings, server API address, or GPS coordinates. That brings us to tuples. Tuples are ordered collection defined with parentheses instead of square brackets. But here is the golden rule. Tuples are immutable. Let me explain you with this an example. Let's print this. It will return the 0th index, this one, and -1 is the last index. It will give us last index, as you can see now. Now let me explain you this in another example. Width comma height is equals to screen res. Print. We are going to use f string here. F string is used many times. Width px comma height. Now look at the line 6th. Width comma height is equals to screen res. This is called tuple unpacking. Python takes the first element 1920 and assign it to width, and takes the second element 1000 and assign it to height in a single line of code. By mistake I have written here 0. It will be 80. The screen resolution is 1080. 120. Yeah, it will be. Yep. Okay. So what I was saying, yeah, and it will take the second element 1080 and assign it to height in the single line of clean code. Okay. Yeah. Here's a tricky Python syntax trap. How do you create a tuple with only one item inside it? Now, watch this. Watch what happens here. Okay, single item. Wrong. Was equals to apple. Print type single item. Wrong. Let's print this. The type is str. Now single item correct is equals to apple. Print type single item correct. Let's print the result. Now if you leave off that trailing comma, Python treats the parenthesis like a simple math grouping. It will treat it like as a simple maths grouping and creates a string. You must include the trail, the last comma here at the end, to define a single element tuple. Which means if you want to create a single item tuple, you have to add this comma at last. As you can see in the output, the first output is simple parenthesis, and in parenthesis I have written apple in simple, which is simple, and the type of that is string. And in the second single item correct, I've added a comma at the last and it's converted into tuple. Now why use tuple over list? There are two main reasons. First is data security. It protects fixed configuration values from bugs. Second, performance. Tuples use less memory in RAM and evaluates faster than dynamic lists. Now next let's look at how to inspect collections. Next let's look at how to inspect collections, perform searches using the in operator and run built-in mathematical aggregations across entire list and tuple. Now we are going to use membership logic and aggregations. Let me show you guys. Test. Oh, my bad. Scores is equals to 88, 92, 75, 95, 88, 100. These are the test scores. Now we have to print 95. We have to check 95 in test scores. And let's check 50. Oh, 50 in test scores. The first output will be true and the second will be false, because 95 is no, it will not work. There's a spelling error. Yeah, now it will work. The first will get true because the 95 is in okay. There it will be list. No, my bad, guys. Yeah, in the list 95 is in the list, but 50 is not. Let's run this code. Yeah, as you can see, now let's use built-in maths functions. Let's use, oh wait, let me give some space here. Len test scores. This will give the output of length. What is the length of the list? And let's use min, which gives the minimum value. I don't know, it will give the minimum value, I think so. Let's test this out. Scores, and let's use max here. Test scores and print sum test scores. And let's run this. As you can see, the length of the list is 6. As you can see, the minimum value of the test score is 8, as you can see in the output, and the max function will give you the maximum value from the list, 888, and the sum will give the sum of these values, which is 1258. Now computing average. We have done the built-in mathematics function. Now computing average. How to calculate average? Let me show you guys average. Let's take this, average score. Average score is equals to sum test scores. We'll divide it by length of test scores. Print, we are going to use f string here, average score, average average scores. You can get the decimal value. There is also a method to get the decimal values up to 2, 3, 4. You just have to add colon dot 2f. Yeah, you just have to do this and just close that. Now it will give you the up to 2 decimal value. If you want 3, you can get up to 3 decimal value, as you can see here. Now the average score, the formula of average is sum and divided by length of the list. Now let's calculate the frequency and search of the list. Print test scores dot count 88. 88. Yeah, 88. Oh, bad. Count here. Paste this to an index 95. Let's print this. As you can see, the test score count 88. And list how many times we have 88. 0 times. If we do this 8, it will print 1 time because we have 8 here. Okay, and the index 95. What is the index? 0, 1, 2, 3. The index function will give us the index of that item in the list. Now under the hood, when you write 95 in test score, Python performs a linear search. It starts at index 0 and inspect each element one by one until it finds a match or reaches the end. And in big O notation, that is O bracket n times complexity for a list of 6 items. It's instantaneous, but for a list of 10 million records, searching a list takes time. In later lectures, we'll learn about sets and dictionaries which optimize search time down to O parenthesis 1 constant times. Now a question every beginner asks is, how do I decide whether to store my data in a list or a tuple? Let's establish clear rules of thumb. Now first let me write a code. To do list. To-do list. Let's to-do list is equals to to-do list is equals to buy. Suppose buy groceries. Buy groceries. Now to-do list will be, suppose you have to pay bills and clean room. Oh, clean room. Yeah. To-do list dot append. Wait. Paul mom. Rahul, comma, Rahul @email.com and 20 07 23. As you can see, guys, here I have made list and tuple. Now use a list when the collection grows, shrinks, or gets reordered over time, like shopping carts, task queues, and messaging feeds. Use a tuple when the group of values belongs together as a fixed schema or recorded where positional context matters, like latitude, longitude, red, green, blue color code, or hosts a prompt. prod. Database connection parameters. Now think of it this way: list represents quantity, many instead of similar items that changes, while tuple represents structures, a fixed set of attributes defining a specific entity. Keeping this design pattern in mind will make your backend architecture significantly cleaner. Before we jump into our practical problem solving lab, I want to intentionally break our code on screen so you know how to read the terminal and fix common correction errors without panicking. Now let me write an example. Color is equals to red. Here I have made a list. Green, blue, print, colors, colors, 3. Let's run this code. Now look at this terminal output. Index error list index out of range. Notice how Python tells us exactly what went wrong. We have 3 items, so valid indices are 0, 1, 2. Index 3 doesn't exist. Now fix, change color in bracket, write 2, or use negative index -1. Let's run this code. It will give us blue. You can also write -1. It will again give us blue. Now let me write another code. Sorry for the background noise. Let's run this code. Now we see attribute error. Tuple object has no attribute append. Python is reminding us that tuples are immutable. You cannot append, pop, or remove items from a tuple. If you need dynamic editing, convert it to list using list server config first. Let's convert this first. List config server config. Now let's run this code. It is still giving us error. There is a name error. Let's run our code. It's still giving us. Let's use another variable. Let's store it in another variable. Let's store it in A. And now if we do this, it'll give us code. It is not showing. Let's just print it. We can do none. We have to change here. Now let's move to bug 3. Inventory, laptop, comma, mouse, inventory dot remove key. Let's look at one more bug that crashes program in production. Wait a minute, there is a first let me fix the name error here. Yeah, no, shit man, keyboard. Now it will work. Yeah, so finally we have a value error. Now value error list dot remove x is not in the list. If you try to if you try to use dot remove an item that isn't inside the list, Python throws an unhandled exception. To prevent this, always write a membership guard first. Now let's write. You have to write the membership guard first. If keyboard in inventory dot remove keyboard. Let's write this program. If keyboard in inventory dot remove keyboard, else print item not found in inventory dot. Let's run this code. Wait, there is a name error. Again and again. Oh, my bad guys, my bad. I just didn't create a list. Inventory is equals to laptop, comma, mouse. Now let's run our code. Item not found in the inventory. As you can see, the code execution is successful. Now I have explained all the topics of list, tuples. Lists are mutable, tuples are immutable, And in lists you can use the built-in functions like append and pop, but in tuple you cannot use. This is the PPT that I've made. There are some problems. There are four problems here. The first one is e-commerce cart manager. The second one is student grade analysis, and the third one is GPS route tracker, and the problem 4 is warehouse stock audit. You can do this problems by yourself. And that's it for today's video. Today we unlocked a major milestone in Python journey, giving your programs real dynamic memory capacity. Let's do a quick recap of what you have mastered today. Collection mechanics, navigating zero-based indexing and extracting custom ranges with slicing. Data integrity, knowing when to use dynamic list for mutable data versus locked tuples for read-only wallet records. Defensive debugging, avoiding classic trapdoors like the dot sort return none trap, and catching index error or value error bugs using guard clause. And real-world back-end logics, building processing scripts for cart managers, grade analytics, and inventory audits. As I've shown you the problems here, you can do this by yourself, or I'll make another video for these problems. So thank you. That's it for today's video. Bye.